Our final type of transformation is a dilation. For the description and the rule, in a dilation, the figure is going to stretch, it stretches, or it shrinks with respect to a fixed point. Another word for stretching or shrinking is enlarge. It enlarges or reduces. So here's the rule. You take the ordered pair and you're going to multiply. See how there's two letters next to each other? That means multiplication. And that's where the x is the scale factor. So you take the scale factor and you multiply it by each ordered pair, each number in the ordered pair. Let's see how this looks. We're going to draw the image after a dilation of a scale factor of 2. That means we take the 2 and we multiply it by each ordered pair, each number in the ordered pair. So 2 times 2 is 4, and 3 times 2 is 6. So our new ordered pair for A prime is 4, 6. We do the same thing for the other ordered pairs. We use the scale factor of 2. So 3 times 2, that becomes 6, and 1 times 2 is 2. And our final one, 1 times 2 is 2, and 2 times 2 is 4. So I have all of my ordered pairs, so now I'm going to plot my new image. So if the scale factor is 2, that means this triangle is going to double in size. So let's go ahead and see how this looks. Okay, so for A prime, we're going to go forward 4 and up 6. So A prime is going to be right here. Remember to label it A prime. Okay, B prime is 6, 2. So forward 6 and up 2 for B prime. And C prime is 2, 4. So forward 2, up 4 for C prime. Okay, so neatly connect. And you can see that our triangle enlarged. It's now double the size, or 2 times the size. Our congruency statement is not a congruency statement, actually. It's called a similarity statement. So now we just do a little squiggle. A prime, B prime, C prime. Okay, so this is our symbol, and now it means it's similar, which means it's the same shape, but it's not the same size. It doubled in size. Dilations are the only transformation that creates similar figures. The other 3 were all congruent. All right, let's look at our next one. We're going to draw an image after the dilation of having a 0.5. 0.5 is a half. All of these are going to become half the size. So our figure is going to shrink or reduce. It will be half the size. So we could do this in a calculator if we wanted to, but I'm pretty sure you could figure out what half of -6 is. Half of 6 is 3, and it's -6, so half of -6 is -3. Half of -4, so we could do in our calculator, we could do -4 times 0.5, but let's, we know half of 4 is 2, so half of -4 is -2. Ooh, we're going to spell math again here. Okay, let's do half. -2 times 0.05, or half of -2 is going to be -1. And half of -4 is going to become -2. And T prime, so this works out nicely because all these numbers are nice and neat. Half of -2 is -1. And half of -6 is -3. and then h prime, and that's going to be -3, -3. So we take half of all these points because our scale factor is half. So let's see how math shrinks or reduces here when we plot it. Okay, so let's go -3, so back 3, down 2. -3, -2 is right here for m prime. Label it m prime. And let's do our next one, which will be -1, -2. So back 1, down 2. It's right there for a prime. Okay, we're on to t prime, which is -1, -3. Ooh, right there. Okay, so we have to squeeze that in, that t prime. T prime. So I can kind of predict here where the next one's going to go. But let's do our ordered pairs. So -3, -3 is right here. So that really shrunk. That really shrunk up. So let me label that one h prime. Okay, connect it, and you can see, yeah, that this original rectangle right here is now half the size right here. And let's write our similarity statement. So we're going to take math, M-A-T-H, the original figure, and our symbol is, we don't have the equal sign, we just have the squiggle or like a sideways S. Let me try that again. So it's just like a sideways S. So we say it's similar to M prime, A prime, T prime, H prime. And that's our similarity statement right there. So that means similarity statement. It means these figures are similar. They're not congruent. They're similar, meaning they're the same shape, but they're not the same size. But the side lengths are in proportion. And another thing about similar figures, all of the angle measures inside are the same. So, it's a rectangle, so they're all going to have 90-degree angles. So even though it shrinks, the angle measures are the same. The side lengths, though, are in proportion. They're similar, but not congruent. All right, let's go to let's go fill in our pre-image, our vocabulary here. So the pre-image and the image are similar. I've been saying that word a few times now. And similar means they have the same shape, but they are a different size. They're either enlarged or reduced. Now, the corresponding angles, like in that rectangle, they were all 90 degrees. The angles still use the word congruent. The angles are still the same or congruent. But the side lengths are not congruent, but they are parallel and they are proportional. They are in proportional in length. Okay, practice 1. It's looking like we're going to graph and label a pre-image and the image after a dilation with a scale factor of 3. So think, the scale factor is 3. Is it going to get bigger? Is it going to stretch, or is it going to reduce? If the scale factor is a whole number, it is going to enlarge. It's going to get 3 times bigger. So let's go ahead and graph our original first. So the original A is -1, -1. So our original A will be right here. And our original B will be -1, -2. Wait, let me back up and label everything. And then our original C is going to be -1, so back 1, down 1. So this is going to be a really tiny triangle. So that's going to be our C prime. Let's go ahead and connect everything. So a little itty-bitty triangle, but don't worry, we're going to make it 3 times bigger. So let's go ahead and get our ordered pairs set up here. And we're going to make everything 3 times bigger. So we're going to go -1 times 3. So our first one will be -3, -3. And then for b, well, there's that negative 3. Negative 1 times 3 again, which is negative 3. Okay, now be careful here because this is negative 3, right, or negative 2 times 3. Okay, so that's negative 6. And then we're doing negative 2 times 3 again, which is negative 6. And then negative 1 times 3 again, which is negative 3. So it's kind of interesting we have the same numbers basically for everything here. All right, let's go ahead and graph it. Hopefully you're getting really, really good at your graphing skills by now. So negative 3, negative 1, or negative 3, I'm sorry, is right here. And that will be A prime. Okay, next up is negative 3, negative 6. So that's right there. So that's B prime. And our final point is negative 6, negative 3. 1, 2, 3, 4, 5, 6. Okay, right here. And yeah, you can see how it's stretched. So let's connect. And there we go. So yeah, it's 3 times bigger. Let's write our similarity statement. I'll put it over on the side here. So we're going to take our original ABC. And do you remember the symbol for similarity? It's just that sideways squiggle. So our pre-image ABC is similar to A prime, B prime, and C prime. And again, what does similar mean? It means they are the same shape. They both have that same right triangle, but the side lengths are stretched or bigger. But all of the angle measures inside are the same. So like there's a right angle right here. That's a right angle and that's a right angle. So they do have the same angle measures. Oh, and here are a few of my favorite things. First, there's my kitty. Isn't she beautiful? And who's this? Oh, hi, Rudy. There's Rudy. And my son Louie. Today's Louie's half birthday, so he can take his temps, 15 and a half years old. And that's Newman. And Mrs. Greenlee's. These are Mrs. Greenlee, the Greenlee girls right there. Okay, let's move on. Okay, here's practice 2. We're going to graph and label the pre-image and image after a dilation. And the scale factor is 0.5. The scale factor is 0.5 or a half. So, be thinking, what do you think will happen to the figure? Will it enlarge or reduce? Will it stretch or will it shrink? If the scale factor is a fraction or a decimal, it's going to reduce. It'll become half the size. So let's go ahead and plot our original figure. So E is at 4, 2. So forward 4, up 2, and put a point. And let's label that E, regular E. Okay, F is 6, 3. So forward 6. 1, 2, 3, 4, 5, 6. Up 3. That'll be right here. And let's label that F prime. Or just F, I'm sorry, that's our original F. And then G is 4, 4. Forward 4, up 4, and put a point. Forward 4 and up 4. 2, 3, 4, right here. And that will be G, E, F, G. Okay, let's connect it up, and we'll have a triangle here. So I'm a little bit skeptical, though. We're going to take this triangle that's already small, and we're going to reduce it. So it's going to be even smaller than it is. Okay, our scale factor is half. So we can do 4 times 0.5 if you needed to do that in a calculator. But we could do this, half of 4. 4 times a half becomes 2. And then 2 times 0.5, half of 2 is 1. And that's for E prime. And let's do F prime. Half of 6 is 3, and half of 3, 3 times 0.5. Half of 3 is 1.5 or 1.5, so that might be a little funky looking on our graph here. And that's F prime. G prime. G prime. Okay, this will be fine. Half of 4, this is going to be 2, 2. cut those in half. All right, so let's plot it. We're going to go 2, 1, forward 2, up 1, and that will be E prime. And forward 3, up 1.5. So this will have to float kind of in between, right about there. So halfway through, that's going to be F prime. And then 2, 2, forward 2, up 2, right there, that will be G prime. So that worked. So we shrunk it down. It's really itty bitty now. Connect those. But it worked. It looks like, you know, here's our original, and it does look like it's half the size, the new one. Let's write our similarity statement. So E, F, G. Do you remember the symbol? It is just a single squiggle. That means it's similar. Okay, and again, when it's similar, that means it's the same shape, but it's a different size. It reduced in size. All of the angle measures, though, inside will be the same. They'll be congruent, but the side lengths will be in proportion.